Hello and welcome to my video, lesson 1.1 on set notation. So this is the introduction to our unit on set theory in 30-2. And so let's just get started right into this and ask ourselves, well, what is a set? A set is a description of basically a list. Basically, it's just a list of items and they're usually in like some sort of category. So there's some sort of description that makes them have similarities with each other. So usually similar items. I mean, I suppose it doesn't really have to be, but generally speaking, well, does it have to be? I think it has to be. The list you could be given might not seem related to you at any given moment, but yes, generally speaking, they have to be related to each other. So here's an example of a list. The number of the people in Edmonton, and so you'd have to make a list of the 2 million people or whatever, and every person would be in that list. So I would be in that list, and so would Jimmy, whoever Jimmy is. I'm sure there's a Jimmy in Edmonton somewhere. And I'm sure there is a Sally. And I'm sure there are plenty of other people. So we can just go like that, ... And who wants to finish off our list? I don't know. I know a guy with the name of Best. And I think that's possibly the best first name. So I'm going to put that as our last name here. So anyways, so we have a whole list of people, and there's a lot more in there. That's what this ... shows, that we aren't listing. So if we look at the other list here, we have, so Edmonton is E, and you can notice that we have this squiggle bracket at the beginning and the end. So if actually better yet is if we drew that squiggle bracket around our list. And if we were thinking about the people in Alberta, actually we would have the same people in the list, and so we'd call it a subset, because Edmonton is in Alberta, so the people that are in Edmonton are also in Alberta. So there'd be more people in Alberta. For example, the people in Calgary would be not in the first part of the list, but they would be in the second list. So what we would say is this: E is a subset of A. So this little symbol here means subset. It means partial set, or a smaller pared down set, a subset. All right. So, whoopsies. So here we have a subset of A. Another thing we can do, or just talking about list set notation. So we're just talking about different things we can do. This is one of our notations. Okay, understanding these squiggle brackets up front here is one of the notations we should know about. These ... things we should know about. Those are ellipses. They're showing the missing parts of the list that we're not writing down because maybe the list is too big. And now in this part, what we would do is we would put the little n in front of our set. And what that does is it actually tells us the population. So before, we were talking about a set of the people in Edmonton. It's the list of people in Edmonton, the names. But now, this n in front means that we count the number of people in Edmonton. So 1.2 million or whatever the number might be right now. I don't actually know the number exactly, but let's go with that. Okay, so that's how we can count the number of items in the set. I want to say list because we do the same sort of thing actually in computer science. And so I took a couple of computing science courses, and basically we have lists and we talk about pretty much the same words, but talking about lists instead of sets. So anyways, that's why I'll try not to slip up, but that's possibly why I might if I do. Anyway, so we have an empty set, so we can write it with this little symbol, which is like a 0 and a line through it. So that can show that it's an empty set. Another way we could write it is with our squiggle brackets, but nothing inside. And so if you counted our empty set, you'd have no items inside there, because obviously it's empty. All right. We also know the words disjoint, or the word disjoint. So that would be two sets of different items or people or whatever that are unrelated from each other at all. So, for example, the set of people in Edmonton versus the set of people in Calgary are disjoint, meaning that they don't overlap, because at any given moment, the people in Edmonton are not in Calgary, and the people in Calgary are not in Edmonton. All right, and the main thing about all of these sets is we look at Venn diagrams, because Venn diagrams are an amazing way to visually see the sets and to compare sets and see where they overlap and all that sort of thing. So let's take a look here at two different sets. The set of even numbers, so I'm going to call this side even, and the set of multiples of 5, so I'm just going to write the word 5 up here. All right, and so now what we can do is we can just fill in this set until 20, it says. So let's go all the way until 20. So 2, 4, 6, 8. Okay, but let's go back to the 5 one. 5, 10. Oh, 10 would be in both. Okay, 12, 14, 16, 18. So 10 is in both, so 15. And then 20 would be in both. Oh, did I put 3 sets and multiples of 4? That's not really what I wanted. I'm just going to delete this last one here. I think I thought about doing that one, but I didn't want to. Anyway, so here we have our two sets. And so this is not fully done yet, because it's until 20, but we don't have all the numbers listed. So let's just write all the numbers that could possibly exist. Whoops. Let's undo that with the other color, or the smaller one. So 1 could exist, but isn't in either of the sets. 3, 5 does exist, 6 does, 7, 9, 11, 13. 15 does exist, 16, 17, 19. So those are all the items that aren't in either of the lists. Okay, so this is all very nice and important, because the items outside are two sets, but inside the universal set, that is all the numbers until 20, all, I guess we'd say all natural numbers until 20, so these ones that are outside in black, those are the complement of the two lists, or two sets. See, I did it again. And so we use a little like apostrophe sort of symbol above or after. So we could go like this. So even union 5 apostrophe, which would be the complement. So we'll look at the union symbol, which is like kind of the U there, in the next video. So I hope this video helps you understand set notation. We're going to continue on in topic 1.2 in the next video. Good luck.